Hi, this is Greg Koopman. In this video, I'm going to show you what can happen in a cube dimension if you change some data in the hierarchies and cause referential and lose your referential integrity. In Kimball theory, he talks a lot about the star schema, and the star schema is basically taking a group of tables that are related and mashing them down into one dimension table. Okay, so the geography dimension is a very good example of this. That's in AdventureWorks, and I'm working with AdventureWorks 2012. I believe it's EE, the Enterprise Edition, even though it doesn't matter whether this is Enterprise Edition or Standard Edition. But the point is this. Let's take a look at the geography dimension inside of a Visual Studio SSDT environment that works. Okay, so right now, what you have here is here's our dimension, right? And we're working off a geography table. All right, so we can explore that table. And as you see, it has basically its lowest level is a postal code, okay? And when you look at how it's built over here, they have a geography hierarchy. Now, if we go and look at the geography hierarchy, we see all geographies. We see the countries, right? So we're in the United States. So I'm going to drill down in the United States. And when we drill down in the United States, we see the states, the states of the United States. Okay? And if we drill down into each of those states, like say, many people are probably familiar with California, we see, actually you're seeing, I believe here, okay, yeah, you're seeing the cities. So here's San Francisco, and Los Angeles is here. Okay. All right. So anyways, in fact, let's go with, let's just go with, so we have the United States there. We have Germany. It's broken down very similarly. We have Hamburg, which we're going to use. And they also break down to different locales. All right. So anyways, this was processed. Okay. I'm going to process it right now. So we see that it works fine. So I do a full build on it. It'll process very quickly because there's only 655 rows in the geography table. So it's done. It's fine. We know the integrity is good. All right. So, and we can visually see it, right? Okay, now, think about this. Many times when you have a hierarchy, not sometimes, let's say 50% of the time, your dimension isn't being, when you create the dimension, you might give someone a spreadsheet, especially like for sales, geographies. And anyways, let's say when someone comes in here and makes a mistake, okay? And they're maintaining that table for geography. And inside since it's a single dimension table, it doesn't, let's just bring that table over here. So here's our geography table that it's working from. AdventureWorks 2012, dim geography. And if we look at this table, you'll see that there's a geography key, there's a region code, state province code, and then the descriptions of those, okay, here's your hierarchy. United States, Florida, Kendall, postal code is one leaf of it, one leg of it. Lakeland is another, etc., etc. If you move up and down this guy, you can see Germany's in here with Searland and Berlin and some sort of postal code, etc. Here's Canada, etc. So we have a good working table here. And I don't know who it's maintained. Let's say it's maintained by somebody in your office, and someone makes a mistake, right? For some reason, a mistake is made, and you don't know that they even are maintaining it, but you bring it in every day, and if there's a change, you change it. You know, it's all automated. So let's say we take Florida, okay? So we take one record, we make one record change in Florida. Right now there's how many Floridas? Florida's the United States, and there's 15 rows. So let's say we go down to Clearwater. It's an easy one to remember, right? And we go to Clearwater, and we're going to change the country it's associated with. All right? So we're going to change this country. We're going to leave Florida. We're going to leave Florida here. We're going to leave Clearwater. But we're going to change the country region from U.S. and the country region name. Both of those we're going to change to Germany. All right, so let's just find the codes for Germany. So when we go up and look at Germany's codes, we see that Germany is going to be country region DE. I guess that's for Deutsch. And then we have Germany for the country English name, right? Okay, so now that's what we have. Okay, so I'm going to go into the editor. I guess I could just do this with a regular update. Maybe I'll just do it with an update. And we're just going to update dim. Well, let's go down there and find that the key might make it just make it a little easier. So the key for Clearwater is 403, right? So we're going to go and we're going to just type in update where geography key equals 403. I'm going to update dim geography. All right. And we're going to set the country code, country region code, equal to DE. And we're going to set the English country region name equal to Germany. All right. And that's going to be where geography is 4003, which is the Clearwater one, right? One row corrected there. So let's go back over and we can look at where province is Florida, right? And as you see in this row here, the Clearwater has been changed to Germany. Now let's think about this. What effect is this going to have on our dimension? Well, our dimension, when we go back to our dimension rather, what we have here, when we look at this, we have one-to-many relationships between each of the levels of the hierarchy. So for example, Germany in this level is a one-to-many state provinces. When I go down to Hamburg, it's a one-to-many relationships between Hamburg and its state provinces. And when we go into our state provinces, it is a one-to-many between state province and postal code. And that's how the hierarchy is. There's no many-to-many in this in this hierarchy, and it's not supposed to be. So what happens when we suddenly take Florida and change it to be under Germany? So now it's under Germany. Okay. Not Florida, but Clearwater, Florida, to be specific. Clearwater, Florida, Almonte Springs, Bradenton, these are all still under Florida. But Clearwater, we're moving Clearwater up to be under Germany, which is the country. So we're skipping the Florida and we're putting Germany here. So since we have Florida and Germany on the same row, and Florida is under the United States also, this is going to lead to a conflict and referential integrity problem, right? But we're using Kimball's model. If we are not using it in a way that checks for referential integrity, which you notice I was able to put that into the table with no problem. If I was in separate tables where I had for example, a country table, or then down to a state table, then down to a city table, and they were all had referential keys and constraints built in to ensure referential integrity, it would not allow me to even enter this error of putting partial Germany on as the country name for Clearwater and Florida in between. Now, if I said Clearwater, Hamburg, Germany, we'd be okay. All right, but since it doesn't line up properly, the Florida is also under the United States. You can't have a one-to-many. When this is a many, when you look at this relationship, these two, now we got a many-to-many relationship, okay? Because not only the United States has Florida, it has all these other states, and Germany has all these other states also, but these two should only have one parent, right? Each of these should only have the same parent. It's the same state, and it needs only one parent, okay? It can only have one parent, but it has two different parents. So that's a problem. And then like I say, in this star schema, it's easy to make this error, especially if you're not working. Dates are the same concept, but you're not going to make many mistakes on dates. But you can make it on locale, geographies, product category areas, and that kind of thing. So let's be ready for this. Now, this is the tricky part. When this happens, what's going to happen when we rebuild our dimension? Well, what we hope will happen is it gives us an error and says, hey, your hierarchy is messed up. It's messed up with Florida, and it's messed up with Hamburg. And that's what we would like it to do. But does it do that? Let's see what it does. We're going to process it now. So now we're going to do a full process on it again. We don't have to do a full, I guess we can do an update, but just okay, so we're getting an error message. So here we are. Let's copy that over into Notepad. See what it looks like. So it helps us a little. So let's see what it says here. It says, in errors in the OLAP storage engine, a duplicate attribute key has been found when processing table dim geography. Column English country region, value Germany. The attribute is country. So what does this mean exactly? Well, when I usually see a duplicate key, I'm thinking that I have two keys. Let's say my primary keys are the same, right? But this is telling me that this country column attribute is a duplicate. Well, of course it's a duplicate. I got duplicates all over the place in there, right? So if I go back to the table, there's no big deal about having duplicates, because look, that's the way you build your hierarchies. You have all these hierarchies. Your duplicates are like on the lowest level, like postal code. You want that be duplicated. That's the lowest leaf level, right? And it corresponds directly to geography key. In geography key, you can't have duplicated. But the rest of these guys are hierarchies. Of course they're duplicated, right? So what does the error message tell me? It's not very descriptive, is it? It doesn't tell me, it doesn't explain that this concept that what would be nice if it said referential integrity issue between levels. This is the way the message should read, if you ask me. It should say, there is referential integrity errors between in your hierarchy for country. You have that concern Germany, and United States conflict. Okay, should say something like that. Something better than this. This does not tell me a lot, but here it is. I just want you to see how this works, okay? So this could cause you a lot of stress because you really don't know why this error is coming up, okay? Because it's, you know, your dimensions worked all this time very well, and all of a sudden it's not working, okay? Because someone made a typo in there or something happened and things aren't lining up right in your referential integrity, and you don't have any referential integrity over in your dimension table. Okay, that's why this happens. So that's the error. And how do you correct it? Well, like I say, all we have to do is go back in and change that back to Florida, you know, or rearrange your hierarchy the way it will still contain referential integrity in your back of business, okay? So I could change, if I found that Clearwater is supposed to be in Germany, I could then go into here and just change this one to Hamburg, Germany, right? And then it will all work, because then we totally moved Clearwater, Florida to Clearwater over to Germany, because I put it into all the hierarchy is consistent then. So let's just do that and see if we can do that. So I'm going to take Clearwater, we're in 403, and we're going to change the state province code. And the reason why I'm telling you this kind of thing is this is a very time-consuming error if you don't know if you haven't experienced it before. Even after you've experienced it a few times, you don't always catch it right away, and you can spend a day looking for this error or longer. Some people, I can imagine that's people that have had consultants that built their cubes, and they know nothing about cubes. There's no way they're going to figure that. They probably will never figure this out. They might, but it will be a painful, long time if people are depending on your cubes. So that's why I'm making this video. And yeah, so there's a province name, and I'm going to change it from that to Hamburg. I guess that's Hamburg. I changed the whole thing to Hamburg. So now I'm going to put Clearwater into Germany. That'll be a new name for them over there. Okay, hit enter. Now we're going to look at Germany again, and we're going to see Clearwater over there, but you're going to see that the relationship has been established with Hamburg in it. So, okay, it's down here. So Clearwater, HH Hamburg, DE Germany. This lines up properly. It's not logically correct, but it lines up correctly as far as referential integrity goes. So we come back over, we're going to rebuild the cube, and now it's going to build the, and now it processed. So now we have pushed our Clearwater city illogically over to Germany. So when we go to Germany, we can enjoy the great sunshine and beach in Clearwater, Florida. Oh, well, in Clearwater, Germany now. All right, so that's how you correct that error. Not fun, not easy, not intuitive, okay? And this can be real pain. And it happens because a lot of your hierarchies aren't built directly from the source tables. A lot of times you have user hierarchies that are built by the users. You define them separately, they're custom built. You usually give your user a spreadsheet to do it by, and the spreadsheet has one flat table in it. Okay, kind of like geography, it's just flat. So it's very easy for them not to make the right relationships in there. All right, so how do you keep this from getting to the cube stage? All right, because once it's at the cube stage, it's not going to work anymore. Okay, you're going to have the error. Then you're going to have to find out, you know, just like I showed you, going through the error is a real hassle. Okay.